Okay, here are the Model 11 Part 3 notes. This is page 3. So just to review here, here's our syntax, norm.s.dist. First value that we enter is the z-score. You must know that. Second is the true-false value for cumulative. We are going to enter a 1, which stands for true. Okay, so just a note here, and we will talk about this later. Sometimes it's easier to just use norm.dist. Notice there is no S there. We are not talking about anything that has been standardized. Then we're going to enter the x value, our mean, our standard deviation, and then again our 1. And we will talk about this on the last couple of pages and make sure that you've got an understanding of both those commands so you can use them when it's easiest. So example 1, female heights are normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches. So our mean, we're talking about female heights, our mean is mu, 65 inches. Our standard deviation sigma is 3.5. To find the z-score for a woman who is 72 inches tall, sometimes you'll see it listed with the subscript here and the value that we're plugging in. Don't get freaked out if you see it looking a little different. So 72, actually let me go ahead and rewrite how we find our z-scores. That is our data value minus our mean divided by the standard deviation. So here it's our 72 minus 65 divided by 3.5. 7 divided by 3.5, we get a positive 2. Notice this is positive 2 because this height, this 72 inches, is above our mean. It would fall to the right if we were to draw this in a normal distribution. Find the probability that an individual woman is less than 72 inches tall. So here's how we're going to do this. And there are more details on the following page. Here's my normal distribution. Here is my mean. There's my z. So 1 standard deviation, 2 standard deviations. I want the probability that an individual woman is less than 72 inches tall, which is the probability that the z-score is less than 2. Let me reorganize here. Which is going to be our norm.s.dist. Our z-score is 2, 1, so it returns the cumulative probability. And just so we have the reminder of how to round, I got 977,24987. I want to the 10,000th place. That's these 4. I'm going to take a look at that 5th value. It is below 5, so this stays the same. So the probability our z is less than 2 is 0.9772, which is also the probability that an individual woman is less than 72 inches tall. So now we want to find, and you know what I should do? I should less than over here. Okay. Find the z-score for a woman who is 60 inches tall. So again, it is that data value that comes first, minus the mean over our standard deviation. I get a negative 5 over 3.5, negative 1.42857. This is a z-score. We're going to round our z-scores to 2 places. So our z-score is negative 1.43. We want the probability of an individual woman being more than 60 inches tall. So here's the thing. You notice before I shaded to the left. Here is my 65, my z-score of 0. Guess I should. Stick z-scores in yellow. So I have 60-inch tall woman. We've got a z-score of negative 1.43. Notice that that normal distribution looks the same, just like it did on page 1. It doesn't matter if we're using raw scores or z-scores. But notice this time, I want the probability that the woman is more than 60 inches tall. So this is going to look a little different. We've got to go back to where we were told the total area under the curve is 1. Anytime we talk about that cumulative probability, that is Excel adding from the left, so the very lowest value possible up to our z-score. So if I want the right side, I need to consider that I want the probability that z is greater than or greater than equal to 1.4, negative 1.43. When I plug that into Excel, equals 1 minus, I want the complement, negative 1.43, 1, and I get, here, let's write it over here, 0.923499788. So again, we're looking at those 4 places. The number after is a 9, so this rounds up. I've got a probability of 0.9235. Notice up above I wrote it with the z-score. Could have used the probability with the inches. X showing us that we're using raw score, Z showing us that we're using z-scores. And you know what I'm going to do? I do want to highlight our Excel commands. So norm.s.dist. Let's highlight these in pink. And the equal. Remember, for an Excel, we need that equal to tell Excel we want it to do the work for us. So if we want the probability, last one on this page, that an individual woman is between 62 and 67 inches tall. So again, my mean is still 65. '67 is up here. 62 is down here. We want what's in between. Here is how we are going to look at this. We are going to find the area under the curve to the left of 67 And then we are going to subtract off the area under the curve to the left of 62. And let me see if I can make our numbers a little easier to see down here. So I'm going to start by finding that z-score for a woman who is 67 inches tall. There's my 67 minus my mean, 65, divided by my standard deviation. And I get 0.5714. I'm going to find my z-score for that woman that is 62 inches tall. Again, that is below the mean, so we should end up with a z-score that is a negative. And we get negative 0.8571. To find the area between them, I got norm.s.dist of my upper z-score, 0.5714, positive, so it's bigger, minus norm.s.dist of negative 0.8571, comma 1. Oops, forgot that as I was talking before. If your Excel gives you a hard time with that, you may have to calculate both of those separately and then subtract the two cells where your answers are living. If I do this separately, just so you can double check, I get 0.7161 minus 0.1957. I subtract those, and I get 0.5204, which is actually what I got when I plugged the whole thing into Excel.